So now I'm going to ask the 6 students who prepared these to come up onto the podium. And we just, I'll have them just briefly introduce themselves and go through the, they've got some slides presented prepared for us, and just to go through those really quickly.
I'm supposed to have an introduction slide and I forgot. So my name is Allison Goodwell and I'm a PhD student here at Illinois in the Civil and Environmental Engineering Department. And my advisor is conveniently Professor Praveen Kumar, who gave the first talk of session 1 for those who were here early enough in the morning yesterday. The topic of this session was the vulnerability of water resources to climate change, and Professor Kumar kind of started us off on a geologic context from thousands of years ago when glaciations and thousands of years of cycles of vegetation led to a highly productive landscape. And a lot more recently, humans have come along and really taken full advantage of that landscape for food and even sped up a lot of these processes. And this was a huge success with the agricultural revolution. And today we've realized that some of this huge success has kind of seemed to result in a lot of complex problems, that most of which involve water and water security. So the next thing that Professor Kumar introduced was some characteristics of solutions that will help to solve these complex water security problems in the face of a changing climate. These solutions will necessitate integration between scales from the individual to the global level. They'll need institutions that can work together and also take advantage of remote sensing and cyber infrastructure resources that a lot of science is starting to use already. Solutions will consist of a network approach to consider interdependencies between different processes and different interacting players. And finally, these solutions will be very place-based because these problems are very site-specific, so their solutions will also be very site-specific. And speaking of place-based, the next 2 talks, the first one was from Professor Rong Vu from Texas, and she gave a very nice talk about the vulnerability of water resources to climate change over the United States southern Great Plains. And the problem in the Great Plains is drought prediction. And in order to really prepare and mitigate for a large-scale drought in Texas, for example, we'd really like reliable forecasts very far in advance. And it turns out that this is actually a very difficult thing to do because climate models don't tend to do so well during the summer over this area. So one of the solutions proposed is an empirical model that uses climate anomalies that the global climate models do really well at predicting that happen in the early spring to empirically predict droughts that turns out to be a better early warning system than the existing global climate models can give. The last talk in session 3 was from Professor Pradeep Mujumdar from India on the vulnerability of water resources for management in India. And the problem in India, there's kind of a wide variety of issues, and basically as the need for water increases, water security becomes increasingly vulnerable to delayed monsoon seasons, coastal inundations, and a lot of other hydrologic impacts dealing with river flow and groundwater availability. And the challenge is that we need to make local scale predictions given global climate models. And in this talk, the solution was presented as a downscaling approach to predict droughts, irrigation demands, urban flood intensities, and a lot of other examples that involve downscaling from what we can learn from global climate models to much smaller site-specific scales. Common themes of this session, I'll just list a few. And mainly water is a place-based science, so just as Professor Kumar introduced in the first talk, the second 2 talks really kind of focused in on how that's really true, and we see site-specific solutions coming out of even global climate models. Also, we talked a lot about feedbacks and nonlinearity leading to uncertainties in climate change that we have to address with our agile institutions. And finally, that these solutions will take advantage of technology, including high-resolution measurements models, and also the comprehension of our own limited prediction skills. So just kind of the comprehension that that uncertainty is really inherent in a lot of these climate models. And I think that's all I have for session 1. Thank you.
All right, first I want to say thanks for staying and listening to 6 students. It's really exciting that there's at least some people in the crowd, so thank you. My name is Lauren. I'm a PhD candidate in civil engineering here at the University of Illinois, and I'm in the Energy, Water, Environment, Sustainability program, so it makes sense that I would report on the nexus between water, food, and energy, a systems perspective. So in case you forgot who gave talks in my session, there were Mark David, James Shortle, and Ashlyn Stillwell. And I just have some pictures from their talks here, just some things that stood out to me as interesting and that I thought might be a good recap of some of the things that were discussed. And so I tried to pull the themes together and see what was common among all 3 talks. And a big thing is that agriculture and power production have impacts on our national water supplies quantity and quality. So things like the localized use of water for agriculture, it leads to major downstream impacts. So we discussed the Gulf hypoxia as well as the issues in the Chesapeake Bay. And thermoelectric power plants are the largest withdrawers of fresh water, and hopefully you've learned the difference between withdrawal and consumption. So shout out to you, Dr. Stillwell. And as a comparison, agriculture is the largest consumer. And also that water use in the home is poorly understood. And by that use, we mean like, is it going to the toilet? Is it going to the shower? Where is it going? So when it's poorly understood, it's hard to understand how we can combat the issues of water scarcity. And also that water treatment to get that water to your home is energy intensive. We're damaging our environment in even more ways than just the basic overuse of our finite freshwater resources. So we have nutrient loading. It's a driver of ecosystem change, and we're seeing ecosystem scarcity. The chain of events from growing corn in Illinois that's then fed to beef, or fed to cows that becomes beef, that then we're applying manure in fields and producing nutrient runoff in places that aren't in Illinois, or perhaps are in Illinois, but we're seeing this chain of events that leads to issues downstream. And also the effluent from power plants thermally pollutes waterways, and we can identify risks to aquatic ecosystems. In particular, that's actually what I'm studying for my PhD. So how we handle this nutrient loading will matter for future food crops. So the nitrogen and phosphorus, it's a question of reducing at the input level versus treating the outputs within the aquatic ecosystems and downstream. And how do we balance in-field practices versus edge-of-field practices versus land use change? And that there are trade-offs that exist in cost, effectiveness, and the willingness for farmers to adopt these practices. And do we want to pay to reduce pollution or have the polluter pay? That's another issue that we're struggling with as far as nutrient loading in our system. And a shifting away from this voluntary compliance policies, how do we get the changes at the farm level in a way that makes sense for everyone? So ultimately, it comes down to understanding the challenges and then presenting reasonable solutions. Nutrient use efficiency requires the right source, rate, time, and place. And how can we relate that to the efficiency of yield? And we need targeted solutions instead of the anything, anywhere approach that was discussed. And then the implementation of less thirsty power plant cooling technologies is a way to help on that end of the sector. And how do we have accurate monitoring and measurement of water use in the home? Because again, all these things play into our water quality and quantity in the US. And with that, in case you have questions for me for some reason, want to talk to me about my research, you can contact me here. Thanks.
Hello everyone, I'm Majid Shafi Jude and I'm a PhD student in Hydro Program in Civil and Environmental Engineering Department, and I work with Professor Shimin Kai. So I have the opportunity to provide you with the summary of the third session of this Congress, which was Coupled Natural and Human Systems for Sustainable Water, Food and Energy. There were three excellent talks in that session which addressed different aspects of sustainable water, food and energy nexus. And they were given by Dr. Kai from University of Illinois, Dr. Hornberger from Vanderbilt University, and Dr. Reed from Cornell University. So although the three talks touched different aspects, or actually many aspects of water, energy, and food nexus and how we should sustainably manage them, each talk was centered around one specific topic, and I tried to address them here. So the first talk was by Dr. Reed, and he brought up the importance of necessary information and data requirements. So he started with asking the question of if we have enough information for managing globally water, food, and energy systems, and if we have, can we sustain them or not? So he used two examples. The first one was the global WEAK model, which is a global land surface hydrologic model, and his analysis showed that this model is significantly sensitive to model parameter uncertainty, especially during extreme events like droughts and floods, which is very important for both hydrologists and water managers. In the second example, he went through rainfall observing satellite systems, which are useful in remotely sensing the precipitation. And he asked the question of if those systems are useful to help us with operational flood forecasting or not. And his analysis showed that these are actually, the results were not showing that those systems are acceptable for operational flood forecasting. Especially some of the results show that we need to have, even under an idealized condition, we cannot get what we want for operational forecasting. Overall, although those uncertainties are important and somehow challenging, we need to include them and accounting them in our models, because uncertainties are inherent and very important in complex systems such as food, water, and energy nexus. Also, there were some concerns about the socioeconomic data and complexity and how citizen science and public information, for example, through social media, can provide us with information to overcome that gap. The second topic that was targeted by Dr. Hornberger was the trade-offs between water, energy, and food in rice production system. So he brought up the case study of rice production in Sri Lanka, in which 33% of the population involved in agriculture. So he did show that the trade-off does exist between water requirement for irrigation and also water requirement for hydropower generation. But the most interesting point of his presentation, at least in my opinion, was the fact that the reported value of energy production and rice production was very close to the semi-analytical frontier. And it showed that there is a kind of emergent behavior from the farmers. Although it also showed that the farmers pay more attention to rice production over energy production, which is something related to cultural and also economic values. He also emphasized that when we are dealing with very complex systems like water, food, energy systems, we need to go beyond a single optimization problem. We need to consider the socio-political dynamics in order to properly address the question. And the last talk, which was given by Dr. Kai, he focused on the fate of the produced food in this food supply chain. He emphasized that a significant amount of food which is produced will be lost or wasted eventually in the food supply chain. However, there are some opportunities and implications for food loss and waste. We are dealing with a grand challenge of feeding 9 billion people by 2050. However, we need to consider that we need to maintain the environment that we have without additional harm. So we need to have a paradigm shift from focusing more on increasing production towards more efficient management of production. And food loss and waste prevention is one of the solutions for this purpose. It is striking to know that food loss and waste accounts for 24% of water, 23% of land, and 23% of fertilizer used for total food production. So therefore, reducing that amount of food loss and waste has some implications for natural resources and also energy conservation. Dr. Kai, at the end of his talk, went through some implications of post-harvest loss reduction for technology, institution, and policy, engineering and policy. He showed us some examples both in developing countries and in developed countries, that how we can provide cost-effective and energy-effective storage, for example, for developing countries. And also he showed us some example how we can use short-term weather forecasts to reduce the harvest loss. But he also emphasized that in order to implement all these solutions, we need to have a proper policy, and also we need to provide farmers and end users with economic incentives. So that's all I have from my session. Thank you.
I'm Allie Gardner. I'm a graduate student in the entomology department, and I'm working with Dr. Brian Allen and Dr. Juma Maturi. And I'm going to give the summary for the fourth session, which focused on water, human health, and ecosystem services. So we had 4 speakers in this session. They were Dr. Leah Kanda from the University of Rhode Island, Dr. Jeffrey Braun from the University of Illinois, Dr. Alan Knapp from Colorado State University, and Dr. Marilyn O'Hara-Ruiz, also from University of Illinois. And the topics and regions that the speakers addressed in this session ranged really across the world, from cholera in Bangladesh to tropical biodiversity to grasslands in North America, and the global burden of mosquito-borne disease, which also is linked to the aquatic habitats where the disease vectors breed. So I was thinking about these very diverse research areas and the diverse departments represented in these talks last night, and what are the similarities between these different speakers and their work. So 3 major themes emerged to me out of these talks, which I'm going to talk about briefly now. The first theme that was common across all of these talks is that water, human health, and ecosystem services are inextricably linked to global climate change. And this really has been a theme, a larger theme of this entire meeting, that water resources are, and the future of water resources are connected to global climate. Dr. Knapp discussed this in a lot of detail, a variety of the anomalies that we'll expect to see in the future, and indeed we're currently already seeing when it comes to rainfall under global climate change. And he also talked about the bearing of these shifts in precipitation on grasslands in North America in the context of his long-term ecological research study in Kansas. So 2 of the observations that he made are that we're going to see, we can anticipate seeing a lot more extremes in terms of climate and rainfall over the coming decades, and we are seeing that already. We've got the average daily rainfall intensity increasing, but at the same time we're also anticipating seeing more dry days per year over coming decades, so lots of extremes in that area. On longer time scales, the risk of drought generally is increasing as well, but meanwhile, the number of notably wet years also is increasing. So on broad scales and fine scales, we're expecting to see a great deal of variability in rainfall. Dr. Braun also talked about this issue to a great extent. He talked about the significance in the changes and in amount and seasonality of rainfall for biodiversity in the tropics. So this was kind of different area of application here. But in general, he observed that tropical species tend to be more sensitive to environmental change since they're unaccustomed to existing in a variable environment, and they're not really necessarily as evolutionarily wired to adapt to rapid environmental change on short timescales. So a particularly striking example to me from Dr. Braun's talk was his discussion of birds in Panama and the negative effect of rainfall variability on the population growth rate of these species. So it's not necessarily a change in the quantity of rainfall over time, but really a change in the variability of the rainfall events that's precipitating this dramatic effect. And to me, that was one of the most interesting takeaways from this talk. The second broad theme of these talks that stood out to me was that in terms of research needs was that large-scale and long-term studies are required for us to get a more comprehensive understanding of all of these phenomena. the interrelationships between water and human health and ecosystem services. And to me, this theme came across most clearly in Dr. Akanda's talk to start out with, his presentation on cholera in Bangladesh, as well as Dr. Knapp's talk on grassland ecology and the long-term ecological research site. So the 30 years of surveillance data that Dr. Akanda showed for cholera in Bangladesh showed an interesting trend that that cholera shows a high degree of seasonality and interannual variability, with the overall trend that during the dry season, cholera becomes more dominant due to issues of water scarcity, whereas in contrast, during the wet season, cholera is more likely to become epidemic due to flood-induced contamination, as opposed to the drought-induced problems in the dry season. And this really wouldn't have come across without the benefit of the long-range data set being available that he was working with. So to me, this draws out, is one example that draws out the need to have these sorts of extensive data sets in order to understand the relationships between water and health. And similarly, Dr. Knapp's rainfall manipulation plot experiment, which took place over a 15-year period, addressed the effects of rainfall patterns and the magnitude of rainfall events, controlled to be independent of the quantity of rainfall. And this yielded some interesting results that really bore out over the long duration study, but as he demonstrated, might have been missed if we only had like a smaller 2 or 3 year snapshots within that 15-year period, as opposed to being able to look at the 15 years of data. So that's a second example that really illustrates the importance of these large data sets when it comes to understanding these ecological phenomena. And then finally, the third theme that I want to highlight is really a call to action for interdisciplinary collaborations in order to advance our scientific and social goals in these areas moving ahead. So Dr. Akanda suggested the importance of communication among different government agencies in the areas of health and water and climate in order to reduce the incidence of cholera. And this same topic also was the focus of Dr. O'Hara-Ruiz's talk on the global mosquito-borne disease burden and how water management fits into the overall picture of this important public health concern. So Dr. O'Hara-Ruiz talked extensively about the history of public health theory and practice, leading up to what she called our modern view of public health that emphasizes not only the disease vector, any single component of the disease, but also the social context, the roles of host hereditary factors, host lifestyle, and social networks in determining mosquito-borne disease transmission. She presented a conceptual model that illustrates all of the complicated causal relationships that link water management practices to risk of exposure to mosquito-borne illnesses, demonstrating the variety of knowledge bases that need to be called upon in order to develop sustainable solutions to this growing problem. And again, the same themes of climate change were threaded throughout her talk as we see vector-borne disease begin to expand into novel environments under climate change scenarios. So on that note, I'd like to conclude by thanking the speakers for their interesting presentations and the meeting organizers for the opportunity to report on this session. And that is what I've done on session 4. Thank you.
All right, I'm Zachary Barker. I'm a master's student in the Department of Civil and Environmental Engineering. My advisor is Dr. Ashwin Stillwell, that Lauren had the honor of presenting or reporting on that session. However, I had the privilege on reporting on session 5, which was entitled Water Crisis or Governance Crisis. And we had 3 interesting speakers, an engineer, a lawyer, and an economist, and it wasn't the start of a joke. But they all came together and basically reiterated the same thing, that this is a governance crisis, not a water crisis. They see that we have the tools to do what we need to do to manage our scarce resource that is water. We just need to do it in the proper way. And I believe Professor Siva said this isn't rocket science, but that might be easier because rockets don't have feelings. And so, as a hydrologist and engineer, Professor Siva attacked this problem as an optimization problem, as a decision-making problem. What are the choices that we need to make in order to make sure there's enough water for everyone and the ecosystem? But he acknowledged that there are some very important things to take into account there, such as culture, values, and preferences that change all the time. So in fact, this is a dynamic optimization problem. Next, we had Dr. Endres, the lawyer of the group, speaking about, well, how do we actually enforce these decisions? Once these decisions are made, who actually carries them through? Who has the authority to do so? And her answer was agencies, whether they be state, local, national, international agencies. They're the ones that need to take the charge. And she mentioned that these aren't agencies that just need to nudge people. She says that they should be really leading the way. We need agency leadership. And she also mentioned not just whittle away at these massive problems such as climate change, but actually take big steps out of them, and she thinks they have the tools to do so. And finally, the economist of the group, Dr. Khanna, recognized that there are some very complex problems when we talk about water, greenhouse gases, water quality, that we have the technology to fix, but it's actually getting people to use those technologies, which is the difficult part. We need to provide the right incentives for them to do so. And that's where crafting these policies is really important. She talked about big data and prescriptive farming as two of the tools that we have that right now we don't really have the incentive for the farmers to use them, partly because the farmers are afraid that if they have that data and that data is available to the government's going to use it against them. So how do we write these policies in a way that everybody wins? And so what I saw this session as is really 3 parts to solve the same problem. The how do we make decisions, the how do we craft the policies to put those decisions in place, and then how do we actually carry out said decisions. And that's all I've got. Thank you.
Hi everyone, my name is Lauren Valentino and I am a PhD student in environmental engineering, which is in the Department of Civil and Environmental Engineering, and my PhD advisor is Benito Marinas, who we all just saw gave a presentation in the last session. And I just very briefly want to tell you that my research focus is looking at novel membrane materials to be used for water treatment applications. So my expertise pairs very well with the session that I want to summarize for you today, which overall highlighted innovative solutions for water conservation, safety, and supply. So we heard from 4 different speakers, both in academia and in industry. Our first speaker was Dr. Benito Marinas, who is the department head of Civil and Environmental Engineering and also the director of the Safe Global Water Institute. And he talked to us a lot about technology for safe global water and balancing the different aspects of water treatment and really the complexity of these problems. So his talk really focused on balancing, for example, balancing the disinfection processes that are used to control pathogens with DBP formation. And then after the second talk that we heard was from Ralph Moshtag from Cars Corporation. He's an engineering manager who oversees the industrial process facility that's located in LaSalle County. So he talked to us about the development and implementation of one of their industrial water use policies or processes. Next, we heard from Dr. Ed Reiter, who's with Dow Chemical Company, and he's actually the director of their one of the programs at their Environmental Technology Center, and he talked to us about using business solutions to bridge the water gap. And finally, our fourth talk was from Julio Vasquez, who is from Halliburton, and he talked to us about water reuse for the hydraulic fracturing industry. So overall, there were really three key themes that stuck out to me during this last session. The first being that the water quantity and quality issues, which are very intricately interrelated, are not only complex, but they have effects on individual, community, and global scales. We heard from our first presenter about individuals in underdeveloped nations who are suffering from lack of access to safe drinking water. We heard about the effects on the community scale from our second, third, and really fourth speakers, who were talking about how local communities are impacted by various water treatment processes and waste strategies, energy strategies, things like that. And then on a global scale, because when we really think about it, water is a global resource, and how it's utilized on these individual and community scales really affects global water usage. The second major theme of this session was that there is really a need for more holistic and integrated strategies to address these water challenges. So this was really focused on by all of our presenters today. On a small scale, we need to think about holistic and integrated strategies. If we consider Ralph, who talked to us about recycling the water within their industrial processing facility. We also heard about this from Ed Ryder when he was talking about Dow solutions to recycle and combine both economic strategies, economic solutions with technological solutions. And we also heard about this from our last speaker, which again was talking about the energy-water nexus for reusing water for hydraulic fracking. And then the third theme that was really highlighted is that we really need to utilize our available resources, and this is in combination with technology advances. Together, combining these technological advances, these innovative solutions to address the water treatment crisis with utilizing nature and utilizing the resources that we have available, taking what we have and recycling it or reusing it, or finding innovative ways to really efficiently use and reuse the resources that we already have are the key to alleviating the world's water crisis. So with that, I want to thank all of you guys for coming today. I'm sure we will have someone else that will wrap up, but I think all of the rapporteurs here are very happy to have been a part of this conference. So thank you all for coming, and we're happy to be a part of this as well.
Well, in case I didn't get a chance to meet you in the last day and a half, I'm Evan DeLucia, Director of the Institute for Sustainability, Energy, and Environment. And I really want to thank the students. We had the last page of the program, notes, the ideas to take away from here, and they filled it in for us. So I think you guys did a great job. So thank you very, very much. Ensuring a secure and sustainable supply of clean water to support human activities without compromising natural ecosystems. And that's the challenge we've been talking about for the last 2 days. It's not rocket science, right? Well, rocket science is easy. I mean, propulsion, gravity, thermodynamics. We can write an equation for that. This is the classic definition of a wicked problem with complex interdependencies. And I think in the last 2 days we prescribed the problem, circumscribed the problem, thought deeply about it, and saw some solutions. So I hope this was useful to you. It certainly was to me. I would be remiss if I didn't thank a few folks, so I want to take that opportunity before we head off to lunch. We had a number of sponsors for this Congress. The Center for Global Studies, the College of Agriculture and Consumer and Environmental Sciences, the Department of Civil and Environmental Engineering, the School of Integrated Biology, and the Department of Natural Resources and Environmental Sciences, and a Hewlett Conference grant from International Programs and Studies all contributed mightily to getting this Congress off the ground. In terms of the Institute, I'd like to take a moment to acknowledge funding from the Baum Family Fund. This was the funding that really launched the Institute 2 years ago and really makes all of this possible. And we have the president of the Baum Family Fund here today, Joel Friedman. So please, a round of applause for Joel. course, we have our organizing committee who put this program together for you. Jim Best, Trevor Birkenholz, John Braden, Jeff Braun, Chiming Chai, Brian Miller, Praveen Kumar, and Murugeso Sivapalan. And of course, I left out the very important person who's also my Associate Director at the Institute for Education Outreach, who really led this effort, Madhu Khanna. So please, a round of applause for our organizers. And then they're probably all hiding outside, but the heavy lifting of all these things, logistics, were run by the Institute staff. And that's led by Jenny Kokini, who's our Managing Director, Tony Mancuso, Communications and Public Affairs Coordinator, Amy Rosenberry, our Office Administrator, Nishant, and Olivia, two new employees working at the Institute who really did most of the heavy lifting for organizing this whole thing. So thank you very much to all of you for coming and for running this. With that, I'll close and invite our speakers to lunch.